Betelgeuse, a gigantic red supergiant in the constellation Orion, has mesmerized humanity for centuries with its deep red glow and enormous size. Astronomers estimate that if Betelgeuse were placed at the heart of our solar system, it would stretch far enough to encompass all the planets up to Jupiter. This massive star marks the final evolutionary stage for stars of its kind and is expected to end its life in a spectacular supernova explosion. In recent times, Betelgeuse has displayed unusual behavior, with its brightness increasing by more than 50%. This dramatic rise moved it from being the 10th brightest star in the sky to the 7th. The unexpected increase in luminosity left scientists scrambling to find explanations. Was it an early warning of its impending demise or simply a blip in its natural life cycle? The stakes are extraordinarily high because, if Betelgeuse were to explode in a supernova, it could light up the sky, turning night into day and providing unprecedented opportunities for scientific study. A star's luminosity depends on its size, temperature, and distance from Earth. Betelgeuse, with a radius more than 700 times that of the Sun, has a relatively cool surface temperature ranging between 3,000 and 3,500 Kelvin, giving it its characteristic red hue. This enormous yet cool star is a prime candidate for a supernova, making its current activities even more intriguing. In late 2019, Betelgeuse once again shocked astronomers by dimming to only 40% of its usual brightness. This event, visible even to the naked eye, prompted intense observations and sparked debates. Some theorists suggested that the dimming was caused by dust obscuring the star, while others believed internal processes might be at play. The potential of an imminent supernova became the central topic of conversation. Using the Very Large Telescope, VLT, in Chile, astronomers captured detailed images of Betelgeuse during this dimming phase, revealing that the star had developed an irregular, lopsided shape. Further analysis indicated that this dimming was likely caused by a massive surface mass ejection, SME, where Betelgeuse expelled a huge amount of material into space. This unprecedented event reshaped the star and disrupted its pulsation cycle. The event was comparable to a volcanic eruption on a cosmic scale, with Betelgeuse releasing 400 billion tons of material, much more than typical solar events. This upheaval not only altered the star's appearance but also cut its pulsation period in half, from 400 days to just 200. Such drastic changes indicate that Betelgeuse is becoming increasingly unstable, raising the question, how long can it maintain its current state? This uncertainty has led astronomers to ramp up their observations, looking for signs of the star's eventual collapse. When a massive star like Betelgeuse exhausts its nuclear fuel, its core contracts under gravity, triggering a supernova. This catastrophic explosion releases vast amounts of energy, hurling the star's outer layers into space and creating a dazzling display visible even during the day. If Betelgeuse were to explode, the first signal would be a burst of neutrinos, subatomic particles that travel faster than light and can escape the star's core. These neutrinos would arrive at Earth hours before the light from the explosion itself. Once the light reaches Earth, Betelgeuse could outshine the full moon, casting shadows and turning night into day for several weeks. A supernova of this magnitude would present scientists with an incredible opportunity to study the death of a star in real time. By analyzing the emitted light, heat, and radiation, researchers could gain crucial insights into stellar evolution, nuclear physics, and the formation of the elements that make up planets and life. To better understand Betelgeuse's behavior, scientists are using cutting-edge simulations to model the star's interior. These virtual models incorporate data from telescopes such as the James Webb Space Telescope, JWST, and the VLT, allowing scientists to study the processes driving Betelgeuse's erratic behavior. The JWST has provided a closer look at the material ejected by Betelgeuse, revealing intricate structures of gas and dust surrounding the star. These observations suggest that Betelgeuse may be nearing the end of its life cycle, offering an unprecedented opportunity to examine the life cycle of massive stars. While scientists estimate that Betelgeuse could go supernova within the next 10,000 to 100,000 years, its recent behavior hints that this timeline might be much shorter. The astronomical community is racing to capture every detail of this cosmic spectacle before it reaches its dramatic climax, ensuring that humanity doesn't miss out on this once-in-a-lifetime event. In late 2023, the James Webb Space Telescope shifted its unparalleled focus to Betelgeuse, uncovering a startling new phenomenon. Scientists discovered that the star, already in an unstable state due to its massive surface mass ejection, had undergone a rapid internal collapse. This collapse was evident through significant shifts in core dynamics, which altered the flow of nuclear fusion reactions. Astronomers observed dramatic fluctuations in Betelgeuse's expansion cycles. Before the collapse, the star's surface expanded and contracted steadily over a 400-day period. Afterwards, this rhythm abruptly shifted to 200 days, signaling a massive disruption in the star's internal structure. This irregularity in the star's pulsation cycle resembles a cosmic heartbeat, suggesting that Betelgeuse could be entering the final phase of its stellar life. Simulations created by astrophysicists revealed that Betelgeuse's core is becoming increasingly unstable as it fuses heavier elements. Stars that reach this phase begin producing iron, a process that marks the final stage before collapse. Unlike other elements, iron does not release energy when fused, causing a buildup of mass that drives the core toward an inevitable implosion. Betelgeuse's erratic behavior has sparked heated debates among astronomers regarding its supernova timeline. While some argue that the recent findings suggest an explosion could happen within the next few centuries, others believe it may still be thousands of years away. One thing is certain: Betelgeuse's time as a red supergiant is quickly running out. A key indicator of an impending supernova is the release of neutrinos, subatomic particles that escape the core of the star just moments before it collapses. Scientists are closely monitoring Betelgeuse for any sudden surge in neutrino activity. Instruments worldwide are on high alert, ready to detect this fleeting signal, which could provide humanity with its first real-time warning of a supernova. While Betelgeuse's supernova will be an awe-inspiring celestial event, visible even during the day, scientists assure us that it poses no danger to Earth. However, its brightness could rival the full moon, casting eerie shadows and lighting up the night for weeks. This event will not only captivate stargazers but also offer an unparalleled opportunity for scientific research.